Let's get started. Wow, full house. Thank you very much for attending. My name is Deepak Singh. I'm a Principal Product Manager at Amazon Web Services. And I'd also like to introduce my colleague, the brains behind the operation, the man with the beard, Miles Ward. So how many of you here know everything about Amazon EC2? The good news is I can't see a single hand because the lights are shining into my eyes, so it doesn't matter. Some of you might be wondering why we have silverware and apples on stage. You'll find out. Also, if anyone has a Twitter account, keep it ready. The theme of our talk is, actually, let me go back. The theme of our talk is scriptable infrastructure. What can you do when you have the ability to spin up resources, orchestrate them, do stuff with them, some of which you'll find out today, when using a simple command line, using programmability. To demonstrate that, and we're going to start off by talking about identity and access management. You might think it's a very mundane thing, but like everything else you'll hear today, these are features that you may be aware of, you might have heard of, but you'll see some very interesting ways that when given programmability, you can create a lot of mayhem and devastation. Those of you at the back, if there's an explosion, it's easier for you to run out, so you can do so. With that, Miles.
Hi, everybody. Thanks for taking the time to come to our little sort of toy demonstration. I'm one of the solution architects. There are a whole bunch of us. So as you were going through this, if there are new questions that you get or other things, please take advantage of our Chalk Talks and the other sort of areas where there's lots of folks that you can ask good questions to. What we've really heard early on from customers that keys are a pain. Who loves key management in the room? Who is stoked about, I can see through the lights and there was actually no hands. So IAM roles as a service from identity and access management. How many folks are currently using IAM roles in their applications? That's pretty good. That's pretty good. So it should be a higher ratio, frankly. The use of identity and access management in general, as we've looked through as a ratio of the deployments, it just isn't high enough. The ability to provide rights-limited credentials to your EC2 instances is so powerful in its ability to subdivide the parts of your application and limit your risk in exposure to access to controls. You certainly don't want the machine that all it's supposed to be able to do is back things up to be able to start up 20 machines. So in order to demonstrate this and a couple of other pieces, we've built some decidedly uncloudy things. And I'm going to say up front, there's an incredible likelihood that all of this stuff will break and fail since it's made out of hardware. So what we're going to do is show a couple of interesting pieces. This controller, what it does is provides an interface into AWS. So it's hooked up to a Python script that we wrote on the plane on the way here. Scott Vandenplas from the Obama team did a little bit of coding with us and made sure that this was all sort of working. So what the IAM role that's present in the application layer that runs this Python code does is just allows you to open and close the ability to execute a very dangerous control called terminate instances. You may be familiar with it. So what I'm interested in is having someone from the audience come up and poke the button. So right up here, the way this works is I hold the little black thing, and you touch the fork.
Okay.
And then we shake hands.
All right.
So touch the fork, and then, no, you have to still be touching the fork.
Oh, all right.
All right. There we go. So now we've triggered a little command down here, and you'll see, oh, you poked the wrong button. Oh no, hardware getting in the way again. So instead, poke the red apple.
All right.
And shake my hand. There we go. Okay. So now, if you're watching down here, totally impossible to see for the purposes of excellent demonstrations. What we've done is we've blocked the user from being able to terminate. So we have another one of our little toys up here that terminates instances. What I'll show you over here, hold on one quick second. This large. Can everybody see this guy? Right there. He says M1 large on him. He's unassuming. Can I have another volunteer from the audience? Real quick. Anybody come on up? Oh, yeah. Here. Sorry. Good call. So that M1 large. So there's a little M on the ground. Yeah, no, well, I made it in them. So now you can see this one over here. It's off trying to terminate the heck out of that instance, and it's not going to be able to do so. So this large will stay running. The little green dot won't die, and we can flip it back the other way if we want. So later we'll sort of turn back on that function. And all of that's built on the behavior of IAM roles. None of you can change or access this instance and manipulate and steal my secret key or my access key and make it so that you can go do the terminate instances command on the rest of my fun machines and mess my demo up, because IAM roles is rotating that credential, rotating it very frequently, applies it into the instance metadata variables, makes it so that those systems are able to inherit that variable, the credential that's used to execute the commands. Very powerful tool for building applications. So we'll show a couple more examples here in a second, but the next sort of major feature we wanted to talk about is custom auto-scaling. So we've shown that we can change the IAM behavior of a service based on demonstration, but we really think that there aren't nearly enough customers, based on our analysis, or sort of look through both hands-on, one-on-one with individual customers, but also in sort of evaluations of the stuff we're seeing come back from the usage of systems, that auto-scaling is relatively popular. There are a lot of folks that make it so that more computers turn on when the CPUs get loaded, or less computers turn on when the CPUs get unloaded. But there are a lot of custom measures that make an awful lot of sense. You may want to trigger off of something that isn't native. So we've added some tools and some features for that. We've made it so that you can put some scripts in on the instance that will report custom metrics to CloudWatch, make it so that your system can auto-scale off of other things that are maybe more valuable, stuff like memory utilization or free disk space, or other measures that are not the natural parts of CloudWatch. I have maybe a more useful measure to trigger off of. How about Twitter? So everybody feel free to send a tweet to, and I don't have a real way to type this on screen other than to type it on screen. So I'll go like this. At AWS Cloud Hack. So anybody who tweets anything to that is going to affect a CloudWatch metric that will impact an auto-scaling group that will drive a very large number, hopefully, of T1 micro instances in this account. So we are auto-scaling in this account every 5 minutes based on a little chunk of Python that's running in here. So now it thinks that there are 6 EC2 instances in our micro fleet. I'll refresh this guy. So the more of you that tweet this thing, you'll start to see here the ones named tweet-o-scaling in the parlance of our times. These ones will go through, and every 5 minutes it'll kill off all the running instances and construct a new fleet of machines sized based on the number of tweets. So we'll watch this thing count up. Oh, I think that's because he turned off the AWS credentials. So I need someone else to come up as a volunteer. Let's turn back on the credentials so that this system works. Who wants to poke fruit? Anybody? I nominate Scott, who built this tool. Come here. Oh, all the better. So we need the green apple. So you could poke it with the fork. I have no idea what that would do. Everybody stand back. You could bite the fork, although it's not aluminum. You can bite the apple. If you bite the apple and shake my hand at the same time, this might work. Totally worked. Yeah.
All right.
So now we've opened the group. Why don't we, here, I need one more person to come up and terminate an instance while we're at it, because that seems like fun. Anybody volunteer? Thank you, my man. So you shake hands and touch the magic M right there, the big copper one. So there it goes.
I see it as a W.
You see it as a W. I see it as a miles. Miles, it works both ways. So we'll relearn this guy. Ding, ding, ding. Let's go over here and watch our large. In here. Refresh. So here's the M1 large terminating as a result of the trigger. So that's it shutting down. Everybody can see that guy there? So again, that's a control that was blocked by identity and access management prior to us opening the control, and then now unblocked based on grabbing fruit. So the systems that we've built, the different sort of architecture components, the reason we're using sort of these strange, silly examples as ways to explain them, they really are programmable. None of this stuff depends on actual buttons and things, and it's really inconvenient to have someone walk all the way down the hall and wait in front of me and shake my hand and poke the fruit. That's sort of an inefficient way to change stuff. It's almost as inefficient as driving down to your data center with extra hard drives and screwdrivers and adjusting the way that your infrastructure is provisioned. So we're really trying to sort of make the point in maybe a little bit of a funny way that we're hoping that you do more to automate and program infrastructure. These systems are designed to take advantage of programmatic management, of programmatic deployment, programmatic definition. So that combination, we think, there's another sort of behavior that ties into that. How many folks are using elastic network interfaces today? ENIs? Couple? So elastic network interfaces create a whole other kind of infrastructure management and control. And for the folks who aren't familiar with them, an ENI is an additional interface on the outside of an EC2 instance. So that interface is a network connection. It doesn't provide additional bandwidth, but it provides logical segmentation and allows you to span multiple of VPC, virtual private clouds, distinct subnets. So that allows you to have multiple routing rules, multiple security groups, multiple connections, both either to your internet gateway or your virtual private gateway. Those connections allow you to build more sophisticated topologies on top of AWS. And it's a set of features, again, that we think are very, very powerful and enable host intrusion detection prevention systems, or rather not host, actual IDS, IPS at the outside layer, as well as mid-tier load balancing and other kinds of behaviors where that ability to move network interfaces between instances, as well as the ability to have multiple interfaces, and as a result, also multiple external elastic IP addresses. So on our largest hosts now, you can provision up to 240 distinct IP addresses on the outside. So a very powerful set of features for enhancing the flexibility of services. Another component here, this instance that we've been trying to terminate so aggressively laughs at our ability to terminate it. You'll note it's back. The M1 large just below Twitter hack is back running. That instance is in an auto-scaling group, an auto-scaling high availability group. So how many folks use auto-scaling to grow and shrink based on load? Yes? How many folks are using it just to save your bacon? I use it to save my bacon. So I don't like it when instances go away. I don't like it when application layer infrastructure takes down stuff, or I don't like it when errant users accidentally turn things off. We have protections for that in the console. How many folks are using termination prevention? Used to that one? Okay. So termination prevention avoids the random grabbing of buttons and poking them things that would turn things off. But auto-scaling prevents all the other kinds of failures that affect instances. So it's an important and powerful way to make it so that your infrastructure laughs at failure. We're really eager. It's one of the core things that we think makes cloud so substantially different from working in a physical environment. I have had lots of computers, and when they break, I have to go get another one. And it takes a whole bunch of time, and it's very complex and typically expensive, and not something that's nearly as easy as start instance. So I'm really looking forward to more folks taking advantage of auto-scale high availability for better high availability. Another important feature that I want to demonstrate. How many folks have used the new Ebs Deployment system as a part of the AWS console? Yes? Folks are using that? See, I knew we would find one that was not particularly used. So I'm going to show, I have built a lot of machines at AWS, and we've made this important part of provisioning systems a lot easier. So I'm walking through, hopefully everybody can see in the back, this is the standard instance launching console experience in the management console. If I start an EC2 instance, say, one of the ones running Amazon Linux, and I want to run it on one of our instance types, one of the important questions that now you get asked that you didn't used to get asked, a whole new panel in this environment, is a question about storage configuration. This used to look like a whole bunch of this. I did a lot of those kinds of scripts where you're going through and figuring out exactly how many disks, configured exactly which way to build demonstrations or other kinds of pieces. So now that kind of configuration complexity for one-offs, for the things you're trying to do just once to test something, is available here now in the AWS console. So as you build new disks, it's as simple as saying, I want 200 gigabytes of provisioned IOPS, 2,000 IOPS storage, and yes, I'd like 10 of those disks. And why not 11? And then I turned it on and say, my boss won't like this bill very much. Smiley face. And hit continue, and off it goes. So that's a lot less work, typically for folks that are building things one at a time. If you have downstream folks that are used to sliding out the rack rails and installing individual hard drives, that's a little more straightforward. You get to dial in exactly the size that you want. That's also available as an override. So if you start an EC2 instance that includes, like say for example, I want to build here from one of my AMIs, not the indestructible ones. Let's go back to East. So I have Amazon Machine Images that have block device mappings that predefine the number of EBS volumes that are attached to them. That console allows you to alter that definition so that you're not stuck with what you set up at some other time. So let's say I want to build a giant Vertica cluster. So that sounds good. From here, now here I've built this long enough ago that we couldn't build 2,000 IOPS volumes. We only had 1,000 IOPS volumes. So you can go through and edit this configuration, remove the disks that don't fit, and add in the disks that do. So that, I think, does a good job of making it easier to provision this kind of storage. To go back to this. So how many folks have had an EC2 instance fail? Me, yes, bummer. Okay, there are all sorts of interesting ways in which EC2 instances can stop working. Almost all of the ones that I have had fail have been because I am not the best developer. So most of the time what that means is I've set something up where I've made it so that the network card deletes itself on the instance starting. Or I accidentally put a bunch of variables into the system that delete all of my ability to use SSH, or I destroy all of the local keys or things like that. So there are lots of different kinds of application development where you can negatively affect your own instances, where you can kind of lock yourself out. Here's another sneaky one that happens an awful lot. What happens when you forget your administrator password on a Windows instance? You really can't find that thing over again. We have this or you lose the key pair that you've used to construct that password. So how do you get back into that data? Is there a way to repair that stuff? We have this pattern that I'm hoping everybody's familiar with, but maybe folks aren't. We call it the sort of beheading or the Frankenstein Solutions. So you can take any EC2 instance that's running and stop that instance and remove the EBS volume that operates as its root drive. That drive then can be reattached to any other running instance for diagnostic and repair and management purposes. This is a lovely backdoor that's available as a result of the power of EBS for moving between instances. So once you've got that attached to another machine, you can access that disk and make the manipulations and changes that you need to make in order to be able to recover that instance, reattach, turn back on, and all things work great. We've heard from our support organizations that it's not just a couple of you that haven't figured out how to do this. So it's important that if you're running into an issue with an instance, that this is one of the ways that you can work through the problem without too much help from us. So another important item, another place where I think the standards for the way that our infrastructure is designed is maybe different than what you'd expect. How many folks are using CC2 or CC1 or CG1 instances today? I have a few. So, so how many of what we've built in the CC class, the original design, the intent for that application was building clusters of compute infrastructure frankly, for supercomputing workloads, for high-performance computing workloads. And a part of the definition of the CC2 and the CC1 network topology was the ability to have enough bandwidth between the machines and out to the other AWS services to provide the kind of performance that a high-performance cluster requires. You need to be able to bring in the data to do the big crunching. So the CC2 network provides 10 gigabits of network connectivity, very, very high performance, very low latency network connections. An important part of that isn't a part of the sort of normal specs that you're going to see. CCs also have very high performance connectivity to EBS. So the EBS service, the S3 service, the internet connectivity on CC instances is very high performance. So compared to an M2 4XL, compared to the M1 X larges, even the M1 X larges or M2 4XLs with our EBS optimized flag, you'll find the network connectivity in the CC instance class to be at least comparable, if not a little bit better than that, for delivering gobs of gigs and pounds of PIOPS. You can build quite powerful infrastructure components for that. To show an example of that and to introduce one of my friends from the Obama campaign, this is a quick picture, I think, of the use of provisioned IOPS and CC2 instances by the Obama campaign. So this Vertica cluster spanned 8 of the CC2 8XL machines, had 22,000 IOP at the time, EBS volumes for a total of 264,000 IOPS as provisioned. And then above that was tested to deliver double. We were able to re-provision on 2,000 IOPS volumes and receive double the performance. So to speak a little bit about this design and the value of programmatic infrastructure, I'd like to introduce Scott Vanden Plas, lead dev for the Obama campaign.
Thank you, sir.
Yeah.
So it was actually, it was very important for us for pretty much a full stack automation in the Obama campaign. We found that specifically with building the Vertica cluster and the power of having the provisioned IOPS EBS volumes behind this and being able to just dynamically move things between these boxes. This is something that I don't think I've ever experienced really in my life prior to this. I would say that the best thing about the provisioned IOPS volumes, being able to move those between these boxes very easily, and then being able to provision all of the Vertica clusters in this particular architecture, this would have taken us a tremendous amount of time prior to this. I don't even know. We actually did have a physical Vertica cluster as well, which took us, I want to say, a month to provision these boxes. And actually, that was on an expedited order. So it was approximately 1 month to get this hardware. And it was not non-standard hardware. This is very basic things. Outside of the Vertica cluster and specifically into the automation portion and what we did there, we actually ended up using Netflix's tool Asgard for deployment. So we ended up being able to script the entire build process of the apps, which we had approximately 200 total. And this is also supported by my team, the DevOps team, of 4 people. So we ended up having somewhere near 2,000 nodes total, somewhere around 200 applications, and I guess the best example of how this really benefited us in an emergency situation was when the hurricane was coming about, was that a week before the election or so? Hurricane is barreling down onto the East Coast. The infrastructure that we built, we ended up being able to essentially pick up all of the critical applications that we had in East Coast that were not multi-region redundant, and then pick them up and replicate essentially the entire critical infrastructure to the West Coast. It took us less than a day. Specifically, the application tier of this and Asgard was very important in getting this done for us. It ended up having, I would say, about 12 hours total, and that was from the moment that we knew we had to move it to the moment like everything was up and running. So I have to say that my experience prior to this was the exact opposite of that. It could not get any more of a polar opposite. And this is something where I don't think that there is any sort of way to say that the amount of power that gave us, the amount of flexibility, and just the amount of comfort, too. Especially when you're in an environment where, I don't know if anyone has worked in politics, but it is not a very technology-savvy area, generally speaking. We were the first technology team inside of any campaign ever. So being able to provide that sort of comfort to an end user that does not necessarily understand auto-scaling whatever that means. It's very visible when you say, hey, a hurricane's coming to wipe out the west or the east coast, and we just moved everything. That is a very tangible thing. Everyone loves it. President says thank you. I don't know. What else can I tell you? Thank you.
So that's really what we built. There's a huge number of infrastructure pieces that we've deployed, and EC2 has all of these sort of nuances and features. There are so many different facets of the application and so many different applications that are being built. There's a lot of opportunity, and we hope that a lot of you take that opportunity to dig in around the different features and the facets of EC2 and the other AWS services, take advantage of the solution architects that are here, dig in with them about your specific application and the things that you've tried to build. I want to bring Deepak up for a bit because I have a couple of questions, and I'm hoping that we can spend a little time talking through together with you. We've talked today in the sort of 7 major features that we looked through, about the nuance of EC2, the distinct parts of EC2 that make it so that customers can meet not only the workload designs and the large-scale things they're trying to build, but also to tune and make automatic the systems they've built. Any other sort of patterns that you've seen from customers or examples of that kind of nuanced automation that's added a lot of value?
Yeah, so the one feature we did not talk about today that if you'd had more time, you would have put them in, is related to Spot instances. There was a panel earlier today on Spot. I think there might be a few more sessions. One of the most common features I've seen is from customers who like saving money, but they also have SLAs on time. So they will launch bids on Spot capacity. They will set up heuristics that say, okay, it's taking too much time, my price is probably not right, the market isn't set. Give me the biggest, baddest, most powerful instance that it can give me because I have to screen a lot of, transcode a lot of video. So being able to take advantage of all these primitives that we give you, whether they be for launching instances, for attaching volumes, for doing auto-scaling and preventing whack-a-mole from happening, that's the kind of features that we talk about. And one of the things that we're interested in throughout this conference is if there's other areas where you feel that actually there's a lack of automation, and if there was more, your life would be easier, we'd be happy to hear. And so my clock tells me we are running out of time. So what we tried to do today was talk about how automation and a number of features, which many of people, I saw a lot of hands go up, but it was never more than 30% of the room, I think.
Yeah.
And so obviously there's a lot of ability for people to take advantage of some of these primitives that we provide, from auto-scaling, from high availability auto-scaling, to taking advantage of network interfaces that you can move around, and build very, very powerful applications and systems that allow you to, for example, move from the US East to US West to handle a mission-critical app a week before a presidential election. So we have some time after this talk happens, so if you have any questions for features, these features, any other features that you'd like to ask us about, we'll hang around and be more than happy to answer. Thank you very much.
Thank you, everybody.